Thank you for inviting me to talk to you today about the World Register of Marine Species and the importance of a stable nomenclature in a world of dark taxa. I'm here today representing worms as the chair of the steering committee, but also in my own capacity as a taxonomist. I want to talk to you today about two main points. Firstly, about worms, what it does and how it can be used, and secondly, about the issue of using a stable open nomenclature and why this is important in the context of the ISA. Since we're all aware of the need for a robust taxonomy and for species-level determinations, I'll not go into too much detail here. We need species-level identifications in order to allow us to make comparisons across datasets, between surveys, and for monitoring of impacts. But what is worms and how can it help? Well, taxonomic nomenclature, the names given to species, allow us to refer to the fauna we are studying in a consistent manner. It allows us to know which species is being referred to, what was found when and where, by using the unique name that's been applied to it. Now, worms brings these names together in one place, providing an authoritative classification and catalogue of names, and it's openly accessible to all. Using worms names can help ensure taxonomic consistency for the ISA by providing the most up-to-date name of the species. Worms nomenclature is also used by other systems, linking OBIS and GBIF and GenBank and BOLD through the AFIA ID or the Life Science Identifier. Just to explain a little bit more about how worms functions, here is a schematic of AFIA, which is the database behind worms. Each name has a single taxon page and a unique AFIA ID, but each name can appear in multiple portals. There's only one entry into AFIA. Here we look at an example sponge species. You can see that this sponge species, Haliclona, is found in the worms portal, but it's also found in the World Porifera database, and it's found in this regional species database, the European Register of Marine Species, and also in the World Register of Introduced Marine Species, since it's an introduced species. So we have one name applicable to multiple portals of the same database. Now, editors are the driving force behind the worms database. There are taxonomic and thematic editors, and they are the ones who look after the entry of names into the worms database. They're largely taxonomic experts, and they're supported by the data management team at VLIS in Belgium. Now, it's this collaboration between the editors and the data management team that's the reason for the success of worms. There's currently over 533 editors, over 500 editors, and almost 300 editors, taxonomic editors, who are editing worms itself, the rest being editors of thematic or non-marine portals. And as you can see here, it's truly a global database. So what information does worms hold? Well, as you can see here, worms has a wealth of information available on each taxon page. I've encircled the most critical information for the ISA or for databases in red here. But I want you to note also, number 13, the deep links that we have between worms and GenBank and BOLD and other databases. On this example taxon page on worms, you can see where to find those pieces of information. You can see here Cyclocaris franki is the taxon name. You have the authority who named the species. You have the classification, whether it's accepted or not. And most importantly, just below the taxon name here, you have the AFIA ID, this short string of numbers, and this longer string of numbers and letters, which comprises the life science identifier. There's lots of other information available on the page, such as distribution, specimens, taxonomic notes, and links to PDFs, information about holotypes. There's a huge amount of information on each page. Now, I want to also tell you briefly how the database can be accessed and used. Here you can see the quick search box, and this is how you can enter any name, taxon name, to find that name in the database. The advanced search page shown here can be accessed from the taxa menu up here. And you can also retrieve AFIA IDs from a list of names. So if you have a list of names from your own work in Excel, you might want to use the Match Taxon tool up here, which can be accessed from the Tools menu. This enables you to bring back all of the AFIA IDs from your own list of names. Now, database managers can also access web services from this same menu item, and this can provide automatic links to the WORMS databases. So due to time limits today, I will point you also to a presentation available which describes the history of WORMS, links, tools and capabilities, and that's already available on the WORMS website. I'd like to move on now from worms to discuss the problem we have of the numerous new taxa encountered in the deep sea. How do we deal with these if we have no name or description for them? Now, I mentioned dark taxa at the beginning of the presentation, but what are these? Now, these are a term first described by Page in 2016 to indicate the growing number of taxa in GenBank without formal scientific names. As you can see from this chart, back at the beginning of the database, the majority of the species had names, almost 90%. As we've progressed through time, we've reached a point where less than half of newly sequenced invertebrate taxa added to GenBank are identified to the species level, i.e. they don't have full scientific names. Now, names are the foundation of our science. They're a means to communicate about biodiversity, yet we're proliferating dark taxa in our need to document this biodiversity. Here I show you an example of how a dark taxon may be given a multitude of interim or temporary names in different databases and how this might cause confusion. So we have a specimen label or a museum collection database where it's given a particular identifier, just species. We know it's not been identified to the species level, but we don't know why. In a publication, it may be referred to as species 1. On GenBank, it may be given a completely different denotion and also an accession number. We move to the BOLD database, it may have the same denotion, species 1 HR 2015, and a different accession number. And then we also move to the bin, which on BOLD will list a number of different taxa with different denotions, and we can't tell whether these refer to the same or a different species because they have very similar, but they could be quite different species. They should be the same. So we have not only a proliferation of dark taxa, but we have a proliferation of interim or temporary names. But we still need a means to communicate about this biodiversity. And linking of biodiversity databases is best managed through scientific names or life science identifiers, such as the AFIA ID. These names don't have life science identifiers. For computers, these accession numbers are perfectly suitable. But for humans, communicating in this way is fraught with mistakes, chances to make errors, and so it's not quite as good. So can we standardize these temporary names for dark taxa and thus improve the links between our databases? Well, the answer is yes, that we can. We can use open nomenclature. But what is open nomenclature? So these are a few examples which we've already encountered. It's when the identification has not been completed because it is not known. It gives you an idea of the uncertainty around an identification. So we have just genus species, species 1, indeterminate, a question mark, CF. These are commonly found open nomenclature terms used throughout databases and taxonomic literature. But we need a robust taxonomy for comparisons of taxa between our databases and datasets, and particularly when we're uploading data to online databases, such as OBIS, GBIF, BOLD, and GenBank. The lack of standardization of this open nomenclature presents a real risk for the future usage of our datasets. Luckily, a standardized set of terms is already in use in taxonomic works, And this was outlined by Sigovini et al. In 2016, a paper which I refer to here and provide you with a link. What we need now is to ensure that these terms are used consistently and that there is a standardized means of entering them into global databases. This is something I'm working on at the moment, producing a paper just about this, mostly with reference to image annotations. As part of this, I provide here a very short, brief outline of proposed open nomenclature usage. When we've got a new taxon, we have simple alphanumeric codes. Like I've said before, we often have species 1 or species A. Now this should be avoided. What we need to do is use a unique, useful coding. And that's because species 1 or species A may be fine in your own data set. If you have species 1 to 6, that's fine. But once you upload that data set to a global database and everyone else has the same species 1 or species A, it becomes impossible to determine if you mean the same thing. So for new taxa, avoid simple alphanumeric codes. If you are uncertain of the identification, then genus species alone should be discouraged. Instead, it should be supplemented with an additional qualifier, and these are either indet, stet, or inc. Stet means when the identification has stopped at that particular level, and this can be for a variety of reasons. For example, there was not the time or the experience of the identifier to continue beyond it, or a decision was made that you would not identify this particular taxon any further in that data set. But perhaps it was a pelagic taxon and you're working on benthic. That's when you would use stet. Indeterminabilis or indet means that the taxon cannot be determined, and this can be used for damaged specimens if you have a specimen, or for images where you cannot see the needed characters to take it any further. Incerta or inc means the identification is uncertain, and this is often used in image-based identifications, for example, of megafauna. It can be used at all taxonomic levels. For example, when you have an uncertain family, you think the animal is in that family, but you're uncertain. You would type Aristidae family inc. Now these open nomenclature signs should be input to the Darwin core fields identification qualifier, and further information about the identification, such as why you were uncertain about it, can be input into the identification remarks field. Here is a simple flowchart indicating how we can choose the open nomenclature sign for a particular type of identification. If you could identify it later to a lower taxonomic rank, you would use stet. If it's unidentifiable later to a lower taxonomic rank, you would use indet. If it's a known species and you are certain, you use the full name and authority and date. If you're uncertain, you would use inc. Now, if this is most relevant to the ISA, if the subject is new to science, you would use a unique code. And this is where we may perhaps have some discussions later. In this case, I've provided a unique code referring to the institute and a sample. And this same unique code is used here if it does not resemble a known species. So this unique coding should be used in all labels in the museum database, uploading to GenBank, and it provides a means to link these databases with a temporary name. So temporary names were already possible to input to worms. They're one of the possible name status available. So here you can see it's indicated as a temporary name. Now, it is possible to add them, but it should only be used for well-defined dark taxa. Now, what do we mean by that? Perhaps we mean that they've already been published on, the publication is in, and the sequences are available to all in GenBank, and it's quite well defined in the publication, and perhaps has been published on more than once. You will note that this particular entry is a species C, which is the simple alphanumeric we've said we shouldn't use, but this can be allowed because this was coined in the 1980s, sometime before these discussions and global databases. So what can you do, in summary, what can you do to help with using a robust and stable nomenclature? where you can ensure that species are identified to the lowest taxonomic level possible. Now, we know it's not always possible to get to the species level, but you need to indicate why it was not. And this may be because the characters were not there, or it was a damaged specimen. We use INDET. So you need to input taxonomic names using global best practice. In this case, it's Darwin Core. We need to use Darwin Core fields: the scientific name field, which is where the taxonomic name goes, the scientific name ID, which is the AFIA ID, and use identification qualifier and identification remarks fields to document the process using open nomenclature. You need to use robust open nomenclature on all platforms where possible: specimen labels, museum collections, databases, and publications, providing links between all these platforms. And finally, with regards to worms, we request that you engage with and provide feedback to worms using the single email address info@marinespecies.org. That will access the various editors, and you can provide missing names that you think should be in the database. And we're very pleased to receive your feedback. Thank you for listening. Here I give you once again the important websites, contact details, and publications where more information can be found. Thank you.